All right, so continuing with this example, we just determined that we need to use a t-test. So our first step is going to be to state our significance level alpha, which we're given in this question to be 0.05. And our second step is going to be to state our hypotheses. So our null hypothesis, if there's no change or no difference, is that the mean ABI for women with peripheral arterial disease is 0.9, which is the same as it is for healthy or normal individuals. And then the alternative is that what we're checking for here is that they have an unhealthy ABI. And unhealthy means that it is less than 0.9. So that's going to end up giving us a left-tailed test. And we're ready here to go ahead and calculate our test statistic. This is going to be a t-test statistic since we know the sample standard deviation. And so remember that's x bar minus mu sub 0 divided by s over the square root of n. Our sample mean was 0.64. We're trying to determine if that differs from 0.9 based on the sample standard deviation of 0.15 over the square root of our sample size, which is 187. And that gives us a test statistic of negative 23.7. In step 4, we're going to calculate our p-value, which we have a left-tailed test. And remember, the t-distribution is still symmetric, centered at 0. But we're way down here at negative 23.7. And in general here, I just want to show you how to find a p-value for a t-distribution or a t-test statistic. So we're still going to go to second distribution like we did for normal CDF, which is right here. But this time we're going to scroll down to t-CDF. And we want the area basically from negative infinity, so I usually use negative 1,000,000, on up to negative 23.7. So that gives us the area all the way from negative infinity until we hit here. So that'll be our p-value. Our degrees of freedom, remember, is a sample size minus 1, so that'll be 186 in this case. And it tells us that that is essentially 0. It's not really 0, but it's 0 to 4 decimal places, so we're just going to use essentially a p-value of 0. Okay. Steps 5 and 6, we usually combine, and that's where we're making our decision. So if we take a look here, comparing our p-value to alpha, our p-value of 0 is definitely less than alpha, which was 0.05. And that means we are going to reject the null in favor of the alternative. And so step 7 here says at the 5% significance level, the data provides sufficient evidence to conclude that women with peripheral arterial disease have a mean ABI greater than 0.9. Sorry, less than 0.9. And so what we're concluding there is that they do have an unhealthy ABI.